optics bell ringer, like I said, so you should have that in front of you. We are on page 33 in my notebook. Again, if you're on a different page in your notebook, then so be it. Then you are. This one should go pretty quickly. And then we're going to talk a little bit about what sound is and how that's different from light. Tomorrow is our notes on the differences between sound and light. So before we start those notes tomorrow, I just want to talk briefly about what you know about EM waves versus mechanical waves as a review. Okay, so part A is, of course, definitions. We have optics, transparent, translucent, which everybody, not just you guys, everybody has a habit of mixing up because they both start very similarly. So we have optics, transparent, translucent, opaque, and then of course shadow. Okay. So who would like to tell us what one of these is? It is best if you use your raise hand function on your iPads. Nathan. Okay, so Nathan's going to pick transparent. He's going to type up his definition for us. If you want to answer one of the other ones, think about that while he's typing. All right, so transparent is a barrier that allows all light to pass through it. Transparent is a barrier that allows all light to pass through it. Who wants to define another one for us? Emily, which one would you like to define for us?
Opaque.
Okay, and what is opaque?
A material or substance that allows no light to pass through.
Whoops, writing this in the wrong place. It is a material or substance. I'm going to call it a barrier because, again, these words are describing the barrier to the light, which is, of course, made out of a material or substance. So it is a barrier, like a gas or a liquid or a solid, a barrier that allows no light to pass through it. Okay? Who wants to answer another one? Gabe?
Translucent.
Okay, and what is translucent?
A barrier that allows some light to pass through.
Perfect. What is an example of a translucent barrier?
A stained glass window.
Perfect. Now, a stained glass window, we talked about how visible light is actually a spectrum of different colors. So if I have a red stained glass window, what light is it allowing to pass through it? What do you think? If I have a red stained glass window. Yes, Nathan, red. Okay? It's reflecting a little bit of red light, which is why you can see the window is red, and it's allowing red light to pass through it, which is why the mark, the quote unquote stain left on the ground is red. But all the other colors not associated with that are being absorbed so that you don't see them. Okay? We've got two more to define. Two more to define. Who wants to define one of them? Skylar? Skylar's gonna pick optics.
Optics.
Mhm.
Yes. Optics is the science and study of how light behaves.
Mhm. Okay. It's the science and study of how light behaves. Beautiful. So our last one is shadow. Who wants to define a shadow for us? I'm gonna pick somebody. Oakley. What's a shadow? You're gonna need to unmute yourself, dearie.
So the shadow is the something that is created by light hitting a solid that is not transparent.
Okay.
That's
So
opaque.
it's it's a region, it's an area. Okay. Let's say an area. Where no light can be seen, or an area where light is blocked. And as Oak pointed out, this is the area created by an opaque object that light isn't able to pass through. Therefore, there's no light on the other side of that opaque object, creating a shadow. Okay. Part B wanted us to compare and contrast transparent, translucent, and opaque matter. So we can use this as an opportunity to give some examples. Okay, so I'm gonna make a data table.
Miss Stewart, can you zoom out a little bit more?
Oh yeah. Okay. divide it into thirds. I've got 3 things. Okay, so we have opaque, translucent, and transparent. It's been 6 days since we learned what these 3 words meant. What sort of observations have you made? What sort of things have you seen that are either opaque, translucent, or transparent? What are some examples? Okay. Nathan said that clear glass is transparent. Stained glass is translucent. And that logs or firewood are opaque. Kylie?
When I agree with the clear glass on transparent, but like we said on that day that we learned it, if it's a sunny day out or something, it can also be translucent because sometimes you can't fully see it, and you can either see a figure or faded.
Right. And so when we talked about that, the interesting phenomena is that your house windows, your house glass is 2 panes of glass. So we still usually classify it as transparent, but that's an excellent observation. That if it was truly 100% all light all the time, then we would even be able to get like a sunburn through the glass. Because remember, UV light is a part of that light spectrum, but it doesn't pass through your bedroom windows. You're not going to get a sunburn sitting by your kitchen window because it doesn't allow that light to pass through. Okay, so that's an excellent observation. We do usually still classify it as transparent because we're talking mostly about that visible light spectrum when we refer to the description of these barriers. Does that make sense?
Yes.
Yes.
Okay. So what's an example? Does anybody have another example of one of these?
I do.
Okay.
Are you allowed to do 2 for 1?
Sure.
Okay, so translucent.
Mhm.
I have 1 could be paper.
Yeah. Anybody who's held paper up to a light, you can kind of see the paper through it.
And I had another one for that.
Okay.
Plastic.
Okay, like plastic bags, right?
Yep.
I'm going to say shopping bags because if we have like a sandwich bag, a Ziploc sandwich bag, what would that be an example of? Mr. Jones?
What? I couldn't hear you.
A sandwich bag, like a Ziploc sandwich bag or the gallon baggies that we put our lunch money in. What might that be an example of?
That'd be transparent.
Yeah, yeah. So we could say like Ziplocs. Okay. Let's see. Now, Skylar said that translucent could be dirty glass. Yeah, so I'm actually gonna think about like if your glass is just kind of covered in like those hard water lines or has a little bit of dirt on it. I'm just gonna think of that just like I would the stained glass, because really what we're looking at is like stained glass, paper, shopping bags. These aren't dirty. Even clean, you can't see all the light through it. Even clean, you can't see all the light through it. any of these transparent things can get dirty and perhaps become translucent, but when they are clean, they are translucent. Emily, did you have something to add? Emily says a box. Okay. I think she means like a cardboard box or even a wooden box is going to be opaque. Okay. Skylar says a book absolutely can be opaque. Okay. Screens. Somebody made an observation. I think it was Nathan, like computer screens. Okay. What about some transparent things? Think back to our classroom. What are some transparent things? Grace?
I had one for translucent,
Oh, okay. What was your one for translucent?
like a balloon, a blown up balloon.
Yeah, okay. Okay. Inflated balloon. Okay. Excellent. Yes, tanks. Emily said Mike's tank had all that transparent glass. Bailey?
I was gonna say a fish tank.
Okay, Luigi's tank, which is a fish tank. And then our fish tank. Even though at the end there weren't any fish in it. It was still transparent. We could still see the things inside of it. Skylar had to keep cleaning the glass so it stayed transparent. Okay. Emily, did you have another one to add?
For translucent, it could be like like a picture maybe.
Okay, a picture. Clayton said that the glasses on a headlight, specifically the headlight, is transparent because that's clear. Clayton, can you think of one for translucent? A last one for translucent? Still along those lines of lights on a car? Okay. Yeah, brake lights. Clayton, what color glass is a brake light? Yeah, it's red. Okay, so even the glass itself on the brake light is red. Okay, and then Emily, what was the one that you had said for translucent?
A picture?
A picture, like a photograph?
Yeah.
Let me test that out here. I got it.
Or it could be opaque. I don't really know.
Yeah, you know what? I don't really know either. Hold on, let's see. I've got some pictures here. Here's one of me with the Easter Bunny when I was in high school. Let's see. Can you guys see the flashlight through it? I think I can.
Yes.
All right. Nice hypothesis, Emily. So let me change the camera view over. Okay. All right, we need 2 more for opaque.
A mattress could be opaque.
Okay, a mattress. How about Gavin's new baby chickens? Are those things opaque? Okay.
I was gonna say a roof. Of a
Roof,
house.
absolutely, the roof on a house. I'm gonna zoom it out just a little bit more, even more, because we need to move on to part C.
You put baby animals, and I literally put Gavin's new baby chickens.
I was gonna say iron.
Iron, a pillow, Aubrey said, absolutely. All right, part C gives us this image. And labels it as opaque. It asks us, how might this image look different if the material was transparent or translucent? Okay, now you, of course, could have just picked one. You could have picked one of those things and transformed this image into that. Okay, but we're gonna do both here. Okay, so we have our barrier, because again, we're describing that barrier. So I'm gonna draw in my barriers. And then I have my light shining on the source. I'm gonna move this barrier up a little bit. Okay. Now, if I was going to have one that was going to be transparent, this top image here, what would this top image look like? How could you describe what would be happening after the barrier? Let's say it's light shining through a headlight, keeping you safe on the road. Your light bulb is here and it's shining. What's going to happen once it encounters the barrier of the glass of the headlight, or thick plastic nowadays? Yeah, Nathan says that all of the light will pass through, and he's correct. So all that light's going to pass through, all that nice bright white light, keeping you safe on the roads at night or when it's raining. Okay. What about translucent? This is those beautiful stained glass windows that we see on old churches and buildings and things. Emily?
Only half of the light will go through.
Half to some, yeah, depending on what's going on here. So let's go with Emily's half. Only half of it's going to go through. The other half is going to bounce away or be absorbed. Okay. Now, before you leave today, before you guys all scamper off, I just want to talk a little tiny bit about light versus sound. Okay? I just want to redirect your thoughts towards that idea, because that's what we're going to be talking about tomorrow. And by doing that, we're going to review what light is. Okay? This is the behavior of light, but what is light? Yes, you can close your book, Carmen.
Electromagnetic energy.
Yes, thank you. It is electromagnetic energy. Okay. Now, the important part here is that this electromagnetic energy is carried on what kind of wave?
Transparent. No, I forgot what the wave's called. Where is
Well,
it
it's an electromagnetic energy. What kind of wave is it carried on?
Electromagnetic wave.
Thank you. Or an EM wave. Okay. Now, sound. Sound is produced by speakers. That's a bit thin. Sound. What kind of energy is sound? This one's a bit redundant. If this one repeats itself, what do you think sound is? Yes, Tyler. If you're raising your hands, I can't see that anymore. Hold on. Emily, do you have your hand up?
No.
Okay.
I forgot to lower.
Okay. What type of energy? When we think about sound, what type of energy is sound? Yes, Nathan. Sound energy. What kind of wave is sound energy carried on, do you think? If it's produced by a speaker. Think about the sound coming out of your speakers.
Miss
It would
Derek.
not be an EM wave. That's electromagnetic. What other kind of wave do you know about? Yes, sir, Mr. Jones.
So when you like light, no, not light, sound when it's coming like out of the speaker,
Mm-hmm.
isn't it not, I mean, not all sound comes out of a speaker.
Correct. Not all sound comes out of a speaker. Think about strumming a guitar string. Okay. But we are thinking about how that sound energy is being carried. And we know that energy is carried on a wave. So we know that this is energy being carried on a wave. So what we're trying to do is we're trying to think of the two main types of waves. If we know light is carried on electromagnetic waves, then we need to try to noodle out what kind of wave is sound energy carried on. Now, when you have something that is vibrating back and forth, like a guitar string or like the mechanic speakers in your computer, then we can kind of noodle out what kind of wave sound energy is carried on. Grace?
A magnetic wave?
Good guess. I think Rebecca's got it. It's a mechanical wave. Okay? So, when we talk about light versus sound, okay, we are talking about some of the main differences, mostly of EM waves versus mechanical waves, okay? So thinking about this idea for tomorrow, I'm sure already your brain's like, whoa, I can already name one difference between the two, or, oh, I already know how they're similar in one way. Think about these things for tomorrow and realize that we are going to be talking about how sound and light are similar because these things are similar and different. Okay? Make sense? The answer is yes, you may leave.